Good afternoon and welcome to this lunchtimes session looking at bus priority at traffic signals. We are recording this and we'll make a copy of the recording available to you and those other people that registered that couldn't be with us live. Probably tomorrow. I'll circulate the slides as well, so you don't need to screenshot and things like that. Please do feel free to ask questions as we go through if you put them in the chat, and we'll have a Q&A at the end. But just looking down the list, there's quite of people that are on the call already. There's quite a few of you that arguably know more about this topic than I do, because you do it on a day-to-day basis, rather than me coming at it from the this is in theory how it works. But anyway, so welcome. So we'll have a quick run through some of the background to bus priority and where it comes from. We'll have a look at the different technologies for priority and some of the standards involved. Then we'll look at when you might want to ask for priority, and have a look at the impact that you can achieve through providing bus priority digitally, and then we'll open up for Q&A. Bit of background. A couple of years ago now, we did a session like this on how traffic signals works, which covers off the background to traffic lights over 100 years ago, all the way through to some of the latest technologies. So if you're interested in that side of things, then if you bob onto the RTIG website, you can have a watch of that. If you don't have an account, then get in touch and we'll set you up with an account. But as I'm sure you're aware, bus priority can be provided in a number of ways, through hard measures, through things like bus lanes and gates, and dedicated filters. Sometimes some of these are on segregated bits of road, sometimes they're on bits of shared road, but we're not going to talk about hard measures today. We're going to talk about electronic or digital ways of providing bus priority, which first sort of started to evolve as a concept and then in real life in the 50s and early 60s. So been around quite a long time in one form or another. In the UK, the first bit of formal guidance by the department was brought out in 2001, so 24 years ago, with a traffic advisory leaflet, and that was the first time that there was a formal reference and recognition that people should be doing things with traffic priority systems, because that can help improve journey times and the service reliability for public transport vehicles. And it went through some of the ways of providing priority, be that physical or using technology. More recently, last year, a new local transport note was issued on bus user priority. The change in terminology from just bus priority to bus user priority. So this is all about actually the user's journey. So it covers not just when they're on the bus and how to get the bus priority. It covers off everything from the point where somebody leaves their home to getting on the bus and then getting off the bus. So it talks about accessibility of footways and where to put crossings and things like that. So it takes a bit of a wider view of it to help make sure that the individual's journey is appropriate. over the last couple of years, there's been a lot more said in guidance to transport authorities about the need for providing bus priority, enhanced partnerships and bus service improvement plan guidance is splattered throughout with the need for improving bus priority. The national public transport strategy also is full of it, and I would expect that the integrated transport strategy that was being developed will have something to say about public transport priority and active travel priority as well. But EPs and BSIPs, there's been a lot of investment that's come off the back of that, because throughout the guidance it talks about the need to increase bus priority significantly from where it was back when they were first introduced. So that's a bit of the background. We can perhaps pick up some more of that later in Q&As. So it's probably the technology that you've come to hear about. So let's dig into that. If we take a step back in time, the first real large-scale implementations of bus priority were carried out using tags. There are still a few of these systems around in use in the world. There's probably still a few in England even, where you've got a tag, a radio frequency tag, that you need to put in the bus, and you put a loop in the road, and the loop detects when the tag is over it and puts a request into the traffic signal. It's fraught with difficulty. Buses had to be fitted. The tags needed to be in the right place on the bus for where the loops were cut in the road. And as I'm sure you're well versed in, loops in roads are prone to failure. And so when it worked, it was very good, but there was an awful lot of things that needed to line up to make it work. Kent Fast Track was a very good example of where a lot of effort was put in, and it showed what you could achieve with loops and tags very effectively. Then the next sort of iteration was you would put some equipment in the bus, which would know where the bus was using GPS or some other similar location device, and at a particular point the bus would send a message over a private mobile radio network, think sort of walkie-talkie type technology, to a receiver in signal head or controller, and request permission. Still quite widely used in a number of places in the States and places like Japan and Singapore. Relies pretty much on line of sight between the bus and the traffic signal. You can sometimes get around a few corners and things like that, but it's really only designed for short range communications. So if you're trying to do some more strategic priority and think about where buses are more generally, then it's probably not the thing to use, partly because it requires black box special equipment in each bus, which is expensive. You need something in each traffic signal, which again is expensive, both up front and to maintain. It was quite widely used in the UK. In Nottingham, we're using the US standard until pretty recently. Elsewhere, Bristol, Yorkshire, London still used an RTIG standard for the over the radio protocol, and it was very successful. But as I say, it was quite expensive to implement and maintain. and as traffic signals became more and more connected, particularly in urban areas, to urban traffic control centres, then the next sort of iteration was that once the bus had sent a message to traffic signal, that was then relayed over the comms between the signal and the UTC, and Scoot or whatever other priority system was being run in the UTC would then decide what was going to happen. That ran over the same protocol as previously, and it allowed some form of central coordination to take place for bus priority. TfL do this still. Places like Doncaster were some of the ones that started to introduce this as a concept when UTCs were first introduced. The bus to traffic signal interface, as I say, was standardized. It's an RTIG standard. It also was used to help send messages between the bus and roadside displays, where there were countdown displays, to clear down. So when the bus left the geography of a bus stop, it would send a message to the display to clear that departure down. But it was reliant on having a private mobile radio network. It required kit, and it was pretty much interoperable. So quite successful in that regard. But it's been largely superseded in the UK now. The next step, as people needed to implement bus priority on more buses and over wider geography because of the need for equipment in the bus and traffic signal heads, with the previous approach, that was expensive and wasn't scaling very well, and so the concept of the bus talking rather than directly to the signal controller, signal head, to talk to urban traffic control was introduced back in the early 2000s, and those were the days when mobile phone networks were less relied upon than they are now, and so buses communicated their location for real-time systems over a wide area, private mobile radio network. In some places that was trunked with multiple receivers and transmitters, and that communication was also used to provide bus priority, and this is fundamentally still the approach that people do now. The communications and some of the details have changed, but fundamentally the same. In the bus, you've got a device that knows where the bus is, and it knows where it is supposed to ask for priority. And when it reaches that point, that message is sent over the private mobile radio network to urban traffic control to request priority. In larger systems, there's often a data broker in the middle, because either you've got multiple radio networks feeding in, or you've got multiple urban traffic control centres involved. So you need to route the messages to the right place. And good examples where this was widely adopted were Yorkshire and Bristol. And then that evolved as operators started to see the benefit of providing real-time information to their passengers through apps, and also for their own operational management purposes. They wanted to know where the buses were. They started providing data and saw the need for that themselves, rather than having to rely on local authority equipment. Buses cross local authority boundaries fairly regularly and move around the country for big groups, so there was a lot of equipment being taken on and off buses. Sometimes there was more than one bit of equipment for ostensibly the same purpose on the same bus because of different local authority systems and things like that. So operators started to pull away from the need for local authorities to have equipment on bus, and they moved to providing location data to real-time systems through ticket machines, which were starting to be able to do more than just issue a bit of paper ticket. They had GPS in, so they knew where they were, and they had communications to the back office through mobile phone type comms. It moved from black boxes on bus to ticket machines, and this is pretty much the way that priority is provided these days. Same approach: bus talks to the data broker, which then sends the message on to the UTC and therefore the signal head. In the current state, in the larger systems where you've got multiple operators and multiple UTCs, good example is West Yorkshire and Nottingham, where you've got multiple operators and things like that. Actually, rather than the bus talking direct to data brokers, it goes through real-time system providers back office, and the priority request is sent through. But it's still fundamentally the bus that knows where it is. It knows where it needs to request priority, and it's passing that through to UTC to make the decision. Bit of a jump where signals are not connected to UTCs. The development of Mover with detectors of varying types, detecting the sorts of traffic approaching junctions, and then making decisions about when to provide green and how long and things like that. You can provide quite successfully a decent level of bus priority using Mover. Lots of locations are doing this, and the advantage is that there's nothing that's needed on bus, so they don't need to have ticket machine that's configured. They don't need any information about where to request priority and things like that. It's much lighter weight for everybody, but it does only cope when those junctions are configured with Mover, so it's not the ideal solution for everywhere. But if you've got Mover, that works very successfully with the right configurations. There are some other slightly different approaches that are starting to appear. Fundamentally, the bus knows where it is and provides an update to real-time systems and back office systems on a regular basis, somewhere between every 30 seconds and every 10, depending on the operator and the configuration of the ticket machine and things like that. Some places are beginning to work with the concept of how do we make this whole system simpler, because when you need to make sure that a bus knows where to request priority, you need files on the bus, you need all of that configuration and setup. That's time consuming and challenging to make sure that every bus has got the latest set of locations and things like that. So actually you can predict pretty accurately where the bus is going to be in a real-time system, and you can do that processing and send that priority request through straight to, in some cases, hardware that's in the signal controller. So in Lincoln, there are buses that talk straight to via a real-time system straight to the signal controller, requesting priority in the same way, going back to the original way of doing it, but via the real-time system. There are some alternatives, similar approach to predicting location in a big systems where the location is being predicted, but talking to UTCs, and this seems to be gaining some traction, as we'll see. The management of some of the files and processes is quite challenging. So other ways of doing it, just rather than the real-time system or the bus making a request at a particular point, sending through to UTC, these are all the bus locations, and you can use that information for whatever you want to do, however you want to use it. So quite often it's not possible to provide a green signal to every bus, but if you know that there's 4 or 5 buses traveling along the same set of road at the same time, you might be able to do something. You at least know where the queues are and road speeds and things like that, so can act as a road probe, as well as the UTC going, actually that bus is really close to the junction, so yeah, we'll just extend the green signal or whatever you're going to do, just based on the bus location, and the UTC makes that decision. There's a few places beginning to talk about doing this approach. There might even be some actually with it implemented, but most of these ways of providing priority relies on a standard set of messages between buses, real-time systems and UTCs. That's RTIG T031. It was developed in conjunction with the UTMC development group back in about 2006. It's been through a number of iterations since, and so currently the current version is 1.2, and the messages include information such as which signal the request is targeted at, whether the bus is running late, so you can then make a decision about, we're going to provide bus priority to late buses, but not ones that are on time or early, because actually then you just cause a problem later on down the road. The actual priority request and information such as at this signal the bus is turning left, so if you've got a filter and things like that, you can make an intelligent decision in the UTC what needs to happen. Version 1.2 is the first one to include feedback from UTC. So up until that point, bus systems were sending messages to UTC, which was then doing what it was doing, and there was no information coming back to the bus systems about yeah, we did something with it. It was just pushing it to UTC, and the questions about well, what actually happens to all of these messages all of the effort that we're putting in as a bus operator, what are we seeing back? So 1.2 starts to provide some of that feedback. That bit's not been widely adopted, but the general standard for messages has been widely adopted amongst the UTC and UTMC community. So Unix, Dynamic, iDocs, etc. They all handle this and support this, and all of the major ticket machine suppliers for buses also support it as well. So you don't really need to worry too much about the systems you've got. You just need to ask somebody to switch it on in the software, and away you go. So that's a bit about the technologies. The when and how is the bit that is the difficult bit still, it has to say. Having sorted out the technology with standards and things like that, when do you ask for priority? It's no good a bus rocking up to a traffic signal and getting to the stop line and going, "Hello, I'm here, please give me a green light." Signals can't respond immediately. They need to have some time to make decisions, or the UTC does. And so what the bus needs to do is, in advance of getting to the stop line, it needs to say, "Hello, I'm here," at the right locations, so decisions can be made. And so to do that, as we said, the bus needs to know where to make those requests from. So in advance, you predefine where those what are called triggers are going to be. You say, at this particular geolocation, make the request. That's a bit of a geofenced location, because GPS, as I'm sure you're aware, it's not always accurate to a few centimeters or even a few meters. It can wander around a little bit, and so it's within this area. When you get to this point, send the request. You can configure a couple of triggers in advance, and so we'll come on to where those might be in a bit. You've then got the "Hello, I'm here," and then once you've been through the junction, you might want to request a clear down. I'm past the junction, you can go back to doing whatever you were doing beforehand, as well as configuring the fact that the service 23 turns left at this junction and the service 52 turns right. So you know which, if you've got indicators and particular movements configured differently, you know which one to trigger at the right point. And because of the need to know which movement a particular bus service is making, there is a task of configuring those trigger locations to individual services, so that when a bus route changes, you need to keep on top of keeping that data up to date. Otherwise, the quality of predictions is going to drop. Once you've configured all of that, that's packaged up into a file, which is then loaded onto bus ticket machine, or black box if you're using not using the ticket machine, or you're using that in the back office, where it's the back office that's making that decision. And so you're moving files around, you're having to keep track of versions of that file, and what versions where on what bus and what back office and things like that. and so takes quite a lot of effort, as I'm sure those of you that do this on a day-to-day basis can attest. So let's just go through the process of requesting priority. So as a bus is approaching a signalised junction where you've got a left turn in this case option, you at a simplistic level you set up a location at which you want the bus to say, hello, I'm here, can you give me a green light? And then you set up a location just after the junction that says, yeah, I've been through, go back to what you were doing beforehand. If it's particularly busy or lots of congestion and things like that, and you need to track how quickly the bus is moving, or if you've got, I don't know, a fast moving road or something like that, you might need to set a request location quite a long way ahead. So you could set a registration request that says, I'm on the way, I'm 400 or 500 meters away, and then when you're closer, you send, actually, I'm here now. But doing that allows UTC to start to decide what it's going to do, start to put in place a green extension or a hurricane, whatever it is, in advance of the hello, I'm here, I'm really close. And in the situation where you've got signals where you've got filters and different timings, where you've got movement A where it's turning left, you need to configure those request locations with the this is bus route 1 because I'm turning left, and therefore I need to trigger movement A, but bus route 2 is going straight on, so I want movement B, please. And in the real world, this might look something like this. So at this junction, buses are coming down from here. You've got a registration request, a reasonable way in advance of the junction. The bus, as it then gets closer, starts to then go, actually, here's the request point, I'm here. And after it's gone through the junction, you've got a clear down to say, I'm clear, go back to doing what you were beforehand. Interestingly, if you're coming the other way, you've got your registration, and then you've got your request just after this bit of congestion that you've got on the road. So this bit is perhaps more free flowing, and so therefore you haven't got long before the bus gets from that request point through to the stop line and through. So that's from an RTP system in Lincolnshire, if you're interested. So the files that have this information, they've got, skipping ahead, they've got the signal ID that it relates to, they've got the geolocations of the trigger points, they include the movement and the public transport route, and that file format about 2020 was standardized in RTIG 042, which is supported by all of the major ticket machine suppliers now. So you can create the files quite easily and not have to worry about which sort of ticket machine it's going to end up on. The managing the triggers is a interesting challenge. Somebody needs to decide where those trigger locations are going to be. Normally that's the UTC that are doing that, and then that then gets allocated to services. Sometimes that's done by UTC, sometimes that's done by local authority, sometimes that's done by an operator. Each scheme needs to work that out and agree who's going to do that. So there's some negotiation, there's an inter-organisational interface there. UTC go, congestion is greater on this section of road than it was a year ago, so we just need to tweak where that trigger location is, move it backwards or forwards. Therefore that update then needs to be reassigned. The operator, if they've got more than one depot, need to provide that to the right depot, and the depot then needs to make sure it gets onto the right buses. And this is a nice simple example with a single operator and a single UTC. You can imagine once you start to get more UTCs who are running priority schemes, operators need to be making sure that the right buses have got the right files. Sometimes that's going to mean actually combining those trigger files into one where a bus is crossing authority boundaries and schemes, or actually splitting up a file because one depot only needs part of the triggers and another one needs another set and things like that. So there's a lot going on with the trigger files, which means that inevitably somewhere along the line at some point something's going to go a bit wrong. Either a few buses aren't going to have the right files and so therefore aren't going to get the priority that they're expecting, or actually something more fundamentally goes wrong and it all falls down. So you need to keep on top of it, and it's not something that is that easy to recover from once something starts to go wrong with that moving of files around and processing of files. So once you put in all of that effort, what are you going to get out of it? Well, if you go back to the original local transport notes that described 20 odd years ago, the benefit, that was journey time reduction. It's going to take less time to get from A to B because you're going to get a green, or you're more likely to get a green light. Perhaps, and in my view, the more important one is journey time consistency. If a bus journey time is consistent from A to B, you can meet the timetable better. You can not, as an operator, need to put in as much catch-up time and leeway because you more consistent A to B times. If one day it takes 10 minutes and the next takes 20, how much time do you build into the timetable for that stretch? It's a challenge. So better journey time consistency is probably the most useful thing. Reduction in journey times is great if it can be achieved, but consistency arguably is the most important, and therefore because you've got consistency you're going to get better service reliability. You're not going to have to cancel as many journeys because the prior journey is so late, for example. In terms of measurements, way back in the 2006, when Sheffield first put in place bus priority, This was in standalone, so this was using T08, where the bus was talking to standalone signal. They were getting average journey time savings of 39 and 131 seconds. So, you know, over 2 minutes at one junction, the average journey time was reduced. So really quite significant, and much better consistency of journey times. Move forward a little bit, Leeds. There was a lot of people from Leeds registered for this, and there's a few of you on the call, so you might have some newer figures than this, but this was what was published in a post-project report, with 400 junctions, 240 with central priority. There was a BCR on the initial set of samples of over 3, and it was estimated that once the full rollout had been completed, the BCR will be over 8. And at peak times, journeys were reduced by up to 8 minutes, which is really quite significant time saving. And again, slightly more recently, Manchester, savings of up to 31 seconds a junction with a BCR of over 30. And the BCRs are really significant numbers from a business case perspective. And that comes about because once you've bought the software at the UTC end and you've got it initially configured, you then can connect up the junctions much more simply than you would need to if you had to put something in each signal controller. It becomes much more about configuration and the availability of people to do that configuration and stay on top of it than it is about actually investing in things on the ground. So you can get some very significant BCRs, as you can see. But what you do need to make sure is that you don't just go, we've configured all of this, it's working nicely, and then walk away and onto next project. It does need to be looked after. We've talked about the trigger files needing looking after, but if you don't keep on top of adjusting the signal timings so that they're optimal for the current traffic patterns, then the proportion and the impact of bus priority is going to reduce over time. So you do need to keep on top of a lot of things to make sure that the impact continues over the years. So that's a run through. If you want to know more, as I say, we've got a webinar that's recorded and available on the RTIG website on how traffic signals work. There is a session on the trigger position standard, going into that in more detail, and how it handles some of the side cases with bus stops before and after signals in close order and things like that, and a version of this with somebody from Hampshire UTC talking about how they're using it as well. So a few things of further watching if you want to find out more. In terms of where bus priority is going in future, getting out that crystal ball and trying to see the future, we've got 2 working groups at the moment, one of which is making some updates to the T031 standard to reflect some of the changes to UTC systems and the new traffic signal numbering scheme, and just generally, just tweaking it and making sure that it's fit for purpose now. And we've got another group which is meeting for the first time in 10 days time, something like that, taking a bit more of a deeper look about actually what does the future of bus priority look like, what should we be doing to get ready for that, what standards might we be needing to develop, what data is needed, and as I say, taking that bit of a longer look to see what we need to do to support bus priority in future. So that's the end of the run through on bus priority. I think we've got something in the chat. Thank you for watching this RTIG webinar. To find out more about RTIG and our work, then please visit our website at rtig.org.uk. Thank you.